Lesson 5-6. 5-6 is kind of like the second half of 5-5. In 5-6, we're looking at the other common triangles, and that's the 30, 60, 90. So it says yesterday, but it's really, the previous lesson. We're going to look at the second common one, and that deals with an equilateral triangle. So first of all, you should remember that an equilateral triangle is when all the sides are the same. Now it tells you to draw in an altitude. An altitude is basically a perpendicular segment, and it doesn't matter which vertex you use. I'm just using this one. I mean, I could have gone this way, but I'm just drawing this one because it's easy. So I drew in a altitude BD, and an altitude is going to make a 90-degree angle. Okay? So it says, what did drawing in the altitude do or create? It's very similar to 5-5 with the square. If you notice, it really creates two triangles, only this time they're 90. But really it's the same thing. It creates two congruent triangles. Now it says find all the other angles. Well, again, I really don't need to do anything with both sides because they're the same. So I'm just going to kind of ignore the left here and work with the right. Well, if this is equilateral, then that means this is equiangular. So these angles were all 60. And if this top one was 60, then that means this is a 30. It also means then that this side got split because it's a perpendicular bisector. So a little bit of a tie back to 5-1, which means this side is a 6. Now I just need to find this missing side, and so I'm going to use Pythagorean theorem from 5-4. So a squared, b squared, c squared. So a squared, b squared is equal to c squared. So that's 36 and 144. 144 minus 36 is 108. So a squared is equal to 108. Now you're going to have to take the square root of both sides. Now I don't know how you want to break that down. If you can think of the multiples of 108. Some people have a hard time with the multiples on this one. If it was me, I mean, I know a lot of the multiples, but 108, the best multiple probably to use is that it's divisible by 36. So it's 36 and 3. So I would think of this as 36 times 3. If you don't know the multiples, then you're going to have to go to another method. But that works out to be 6 square roots of 3. So this is 6 square roots of 3. I'm going to show you another example here in a second, but kind of like 5-5, I want you to start to look at these numbers and see if you kind of notice anything. So let's do another one here. Let's take an equilateral triangle, which this might not be perfect because I'm just freehand drawing it here. Okay, and if you were here, I'd tell you to give me a side and just make it kind of small, so maybe we use 20. That means all of these are 20. That means these are all 60. And when I drop this down, that makes a 90. And that makes this 30 and 30. And it doesn't matter what side you use, the left or right. I'll use the left this time. That makes this a 10. So I have a 20, a 10, and now I need to find that. So I'm going to go a squared plus b squared is equal to c squared. So that's 100 and 200. No, 20 squared is not. It's 400, sorry. Then I'm going to subtract 100. So I get a squared to equal 300. Well, hundreds are really nice because hundreds can always be think of as 100, which is perfect, times the number. So 100 times 3. That's 10 square roots of 3. So if I go back up to my picture here, this is 10 square roots of 3. Are you noticing a relationship with this number, this one, and this one? And maybe let me see if I can kind of fit them side by side here. Move it over just a tad bit more. There you go. So now you can kind of see, notice 12, 6, 6 squared to 3, 20, 10, 10 squared to 3. Should be kind of noticing a relationship. So down here where it says 30, 60, 90, let's just draw one of them so it doesn't confuse you here. So we'll just draw one, but it's basically half. There's two of them, and there's your 90. Let's make this the 30 because it's across from the shorter side, and we'll make this the 60. Okay, so it's basically the right side. Now what I'm noticing is the 6 and the 6 kind of like got repeated. So let's call this x. Then this was just x square roots of 3. And then the hypotenuse would just be double. So if you look back at the other example here that I had, the 21, notice if this is 10 on the bottom, then the vertical one would be 10 squared roots of 3, and then the hypotenuse one would be double it, so 10 would be the 20. So that's the relationship that you need, and so that's really the information for this lesson. So now it's just a matter of practicing some of the problems. So let's take number 1. Across from the 30, they give you the 5, which this is x of the rule. So this is the 5. So don't really worry about these variables, okay? What I want you to think about is this is one's across from the 30. So the hypotenuse is going to be double, right? Because that's what we saw here, it's double. And then the other leg is going to be this number, square roots of 3. So it's going to be 5 square roots of 3. So what I almost want you to do is when you get to these problems, I almost want you to white out or ignore these variables and just find the missing sides, okay? So again, notice across from the 30 is the 8. Well, that means the hypotenuse is going to be double. So the one across from the 90 is going to be double. That means the one across from the 60 is going to be that number, square roots of 3. Okay? Now, if you don't see that, or you're not sure, or you're still having problems, what you would have to do is imagine this triangle, and then here's the other part of it. Here's the isosceles. See how I kind of drew it in? If this is 8, then this must be 8, which means the whole thing is 16. And because it came from equilateral triangle, as we see up here that's highlighted, then if this is 16, then this is 16, and this is 16, and so on. So if you don't remember this, you can always recreate the other part. So like number 3, if you don't want to use the shortcut, what you could do is you could draw in the other part of the triangle, like this. And if this is 10, that must mean the whole thing is 20, which they don't really ask me for, but this would have to be 20. Now you'd have to use Pythagorean, a squared, b squared, c squared. But if you can remember the rule, then whatever this number is, it's just that number, square roots of 3. So those would be your 2 missing pieces, okay? Sorry, I got a little bit interrupted there for a second. But now, if we move on to the next page here, notice more triangles, okay? But notice they're a little different. See, in the last examples, they were always giving us the one across from the 30. But now they're giving us the one across from the hypotenuse. So this one, by the rule, is equal to 2x. Well, if this is equal to 2x, then how much is this? 12. And once you know the short one, the other leg, the one across from the 60, is going to be that number, square roots of 3. See, again, if you don't want to remember the rule, you'd have to draw in the other side of the triangle. And notice if this is 24, then this whole thing would be 24, which means half would be 12. Okay? So there's a couple ways you can look at these, but you gotta kind of pick a way. So let me walk you through one more. It's across from the 90. You always start with whatever they give you. So you look and say, okay, this is what I'm given, and it's across from the 90. That's going to equal 2x, which if I solve, means this is 11. Once I know the short leg, the longer leg is just that, square roots of 3. And that would be your answer. So why don't you try numbers... Why don't you try, actually just try 6, because this one switches it up a little. So try 6. Go ahead and pause it here and go ahead and try it. All right, hopefully you tried it. And on number 6, this is actually 2x. So if I divide by 2, that means I get 9 square roots of 3. Okay, that's my short leg. The longer leg is that number times the square root of 3, which is really 9 square roots of 9, which is really 9 times 3, which is 18. not 18, why did I say 18? 27. Can't do my algebra here. 27, sorry, apologize. Must be Friday or something. 27. So you still have to kind of follow the rules. Just this one was a little messier because that square root of 3 was in there, where before when I divided it off, it came out really nice. So if you notice, this whole section right here is when they give you the hypotenuse, okay? If you notice in the next section, they're giving you the one across from the 60. So now they're giving you the longer leg, okay? This one, by rule, is going to be the x square roots of 3. Well, notice, if I were to divide off the square root of 3, these just cancel. So x is just 7. Remember, if this was 7, this would have been 7 square roots of 3, so it makes sense. Then we just have to double for the hypotenuse, which is 14. So you really just have to look at what do they give you, okay? So let's try another one together. The 60 is across from the 9, so that's going to equal x square roots of 3. Now, this one was almost nicer because it had the square root of 3. This one I'm going to have to figure out. So 9 equals x square roots of 3, so you're going to divide by the square root of 3. So we have 9 over the square root of 3. We're going to have to rationalize, so square root of 3 over the square root of 3, which is 9 square roots of 3 over the square root of 9, which is 3. So 9 divided by 3 is 3 square roots of 3. You have to reduce this. Then for the hypotenuse, you have to double it. So you're going to go 6 square roots of 3. Okay? That one gets a little tricky. I will say that one's a little difficult. Number 9 is very similar. So why don't you actually pause it here and try number 9. All right, hopefully you've paused it. Number 9, what you would do, because again, they're giving you the one across from the 60, so that's going to be 15 is equal to x square roots of 3. So you're going to divide by the square root of 3, but now you got to rationalize. So you're going to have 15 square over square root of 3. You're going to multiply by square root of 3 over square root of 3. So that's 15 square roots of 3. That's essentially the square root of 9, which is 3. 15 divided by 3 is 5. So the answer here is 5 square roots of 3. For the hypotenuse, you just have to double that. So that would be 10 square roots of 3. Okay? These require some algebra, and that's why I was trying to hint at the beginning of the chapter, that it really does require you to know some of your algebra. So why don't you try these last 3? So why don't you go ahead and pause it here and try these by yourself and see if you get them right. All right, hopefully you've paused it. Number 10 is actually the best case scenario. And number 10, if you notice, they give you the side across from the 30. So in rule, that is the x. So the hypotenuse is just double, and the one across from it is just 4 square roots of 3. So this is like the best case. This is like what you want. You want to be given the one across from the 30. The worst case is when they give you the one across from the 60. Which even number 11, that's what they do to you, but it's not too bad. So see how they give you the one across from the 60? That's going to make this x square roots of 3. Well, when you divide off the square root of 3, then you're just left over with 5. That's going to be the short leg. Then the hypotenuse is always just double. Okay? On number 12, again, they give you the one across from the 60, but the problem is it's not in the radical form. So we have to take 12 is equal to x square roots of 3, and we have to solve that. So we divide off the square root of 3, and then these cancel. And once again, we have to rationalize. 12 over the square root of 3 times square root of 3 over square root of 3 is 12 square roots of 3. That's the square root of 9, which is 3. So that's really 4 square roots of 3. Then we have to double this, so that's 8 square roots of 3. And then that would be our answer. These ones are a little bit more challenging, and we're going to do some more practice with them, but that ends lesson 5-6.